Hello students, in continuation of our previous lecture, I will explain here the filter circuits via the operation amplifiers with some elements like resistance and capacitors. So here we will first discuss the low pass filter circuit. So in low pass filter circuits at a particular cutoff frequency, we have passed the frequencies, and above that cutoff frequencies we have attenuated the frequencies. That is called the low pass. That is denoted by its frequency response between the gain and frequency. So here we will discuss that according to cutoff frequencies between 0 to fc, that is shows by pass band, and above from cutoff frequency, that is shown by stop band. So it is basically a practical frequency response curve by which we have gradually decreased the frequency from higher to lower side and passes the frequencies from below the cutoff frequencies, and above the cutoff frequencies it is stop band, shows mean attenuate the frequencies. So it is basically the integrator circuit by which we have designed it, low pass filter circuit. In this case, a capacitor is attached between the input and output circuit as a feedback network with parallel with resistance, feedback resistance RF. So in this case it is work as an integrator circuit. So in this case it is passes the low frequencies and attenuate the high frequencies. So in this case when we talk about the high frequencies, it is acts like a short circuit of the capacitor. When the circuit is short, in this case our output gain of the amplifiers goes to 0. So in this case our output is 0 in case of high frequencies. So it is attenuate the high frequencies. But in case of low frequency, it is acts like open circuit. So in this case it is an integrating circuit and inverting amplifier circuit. So we will take the output in terms of transfer function, that is denoted by minus RF by R1. So it is the response and circuit diagrams of the basic low pass filter circuit, which is work as an integrator. Next is our basically the high pass filter circuit. In this case it is work as a differentiator and removing the capacitor from the feedback unit, and it is attached with the series resistance R1 with respect to voltage source, input voltage source. So in this case I will show here the frequency response graph where cutoff frequency basically fc, where it is basically the high pass circuit. So it is passes the frequencies above fc and attenuate the frequency below fc, and it is shows by the graph here between the gain and frequency. And in left side it shows the circuit work as a differentiator where we use it. In this case basically it is basically the high pass filter circuit. So C1 acts like a short at frequencies f is greater than cutoff frequency, means we have when the capacitor is short here. So in this case we have taken the output in terms of transfer function gain with feedback, that is basically AF is equal to minus RF by RN, because it is a non-inverting amplifier circuit. And in case when we talk about the low frequencies, it is acts a open circuit, so it is blocks the low frequencies. So it is the basically the circuit diagram and the frequency of the response of the high pass filter circuit. Next when we talk about the band pass, so band pass filter circuit means it is between the talk about the band between the lower and high cutoff frequencies, that is denoted by FH and FL. So it is passes the frequencies between the FL and FH, and below FL and above FH it is basically the attenuate the frequencies. It is denoted by that circuit, and the frequency response curve where we show below the FL stop band and above FH stop band, and below the FL and FH we have take here the frequency response and shows the dB curve between that and the 2 dB frequencies, where we shows the 20 dB per decade at the lower and higher cutoff frequencies, where we achieve the gain near to AF by √2, that is 0.707 AF. dB 3 dB frequency is called the FL and FH, that is called the 3 dB bandwidth. So according to that that is the circuit diagram, where is the combination of low pass and high pass circuits. In this circuit I will show here. So in this case basically there are two types, wide band pass filters and narrow band pass filters. So according to that, when we talk about the wide band, that depends on the quality factor of the Q, means basically when the Q factor is less than 10, that is denoted as the wide band pass filter, and when the value of q is greater than 10, then it is denoted by the narrow band pass filters. So we will define basically the formula that is noted by q is equal to fc by bandwidth, means fc is the center frequency and bw denotes the frequency difference between the fh and fh minus fl, that is denoted by bandwidth. So when we say that when the q factor is increases, so bandwidth it decreases, means it is denoted by narrow band. So here the q is greater than 10. When q is less than 10, means q is decreases, so bandwidth is increases. So in this case it shows by wide band. So it is measure of the basically the frequency selective network that depends on the frequency ratio or frequency figure of the merit and quality factor. And wide band pass filters, when we talk about the center frequencies, that is basically the formula fc is equal to under root fh into fl, where fh higher cutoff frequency and fl is the lower cutoff frequency. So in a narrow band pass filters, the output voltage peaks at the center frequency basically. So next when we talk about the band reject filters. So band reject filters basically band reject means opposite of the band pass filters. So here we have fh and fl, below fh and fl we have removed the frequencies, and from 0 to fl and more than fh we have take the frequencies. So in between fh and fl we will stop the frequencies, so this is called the band reject or band stop or band elimination filter. So in this case we have introduced a low pass filter circuit and high pass filter circuit with a summing amplifier. So output of the low pass filter circuit and high pass filter circuits are connected in parallel and outputs to be applied to a summing amplifier. So in this case I will discuss here that is the circuit diagram where the upper and lower circuit, low pass and high pass filter circuit, that is, and particularly the output voltages are feeding in the basically summing amplifier. And it is a graph where we showed that the lower and higher cutoff frequencies are 200 Hz and 1 kHz, and we'll calculate here the center frequencies from the formula S equal to F under root FHFL, that is 447.2 Hz. And in mid where it shows that below FH and above FL, here shows the pass bands, and below that reject the band. So here we take the GAN, and that is the depend on the values of RF after LF designing. What we have choose the resistance values, according to that we have taken the value of the gain of the gain of this circuit. So according to that, here shows according to this graph where we shows that at the mid frequency range gain is nearly equal to f, and the lower cutoff frequencies, the FL FH, that is decreases in terms of 1.414. So here next when we talk about that in terms of the all pass filters. So all pass filters are the circuit that is basically the passes the all frequencies. So it is also called the delay equalizers or phase correctors. So it is the filter that passes the all frequency components of the input signals without the attenuation. So its function is to change the phase of the signal without affecting its amplitude. So it is called the phase shifter also. So when the signals are transmitted over the transmission lines such as telephone lines, then undergoes a phase change in the signal. So to compensate these phase signals in terms of all pass filters are required. So it is also named called frequency comparator. So in this circuit shows here when we same the values of RF equal to R1, then we found out the gain, and the gain we have found out the V0 is equal to basically V0 by V in terms of 1 minus J2 pi FRC upon 1 plus J2 pi FRC. So here basically the components are basically R, C and F, by which we have taken the gain value between the output and input voltage, where frequency in Hertz and the capacitor values and resistance values here. So in this case also I have denoted the phase changer, the value of the graphs, phase shift between the input and output, where we shows the output is a phase lagged by the input voltage with respect to 90 degree. So via this I have also explained that according to that when the gain value V0 by Vin, that is basically unity, when V0 is equal to Vin throughout the useful frequency range. So by the phase angle phi, we have calculated here the phase shift between the V0 and Vin, that is basically the function of the frequency. So according to formula here phi, where we shows here the phi is equal to minus to tan inverse 2 pi f RC divided by 1, where f in frequency in hertz, r in ohms, and c in farads. So according to that, according to our previous graph, we have showed that when the value of r and c are fixed and the frequency range from 0 to infinity, we have shown here the v naught lags v in by 90 degree, shows by that graph. But when we have put the r and c are interchanges, then then the phase shift values are become positive, and the v naught leads the v input voltage. So basically it is the basic things by which we have discussed here, the different type of filter circuits via the op-amp with the different type of active devices with the some different type of r and c values. By this we have shown the different type of active filters. Thank you.